Ladies and gentlemen, I'm delighted to welcome you on behalf of Current to this first of its kind webinar, Spain's Power Network towards a zero emission future, the role of the grid and innovative technologies. I'm Susanne Nies, I'm the board chair of Current and general manager Germany of Smart Wires, a founding member of Current. So when I say first of its kind, it is because Current has started a series of webinars focusing on the national situation when it comes to the role of the grid and innovative technologies. We are very happy to see so many attendees to today's webinar. We have more than 140, and we invite you to actively participate, to ask your questions through the Q&A or through the chat so that we can take those into account. Could I have the next slide, please? The agenda for our meeting today is that we have a keynote speech by the Director of Transmission from Red Eléctrica de España, Concha Sanchez. We have a panel with Ricardo Renedo Williams from DG Energy, Andres Ramos Galan from the famous Comillas University in Spain, Norela Constantinescu, who is the boss of ENSOE's research and development and innovation work, Mario Patino, Smart Wires, focusing on Latin America, and finally, Dink Memis from Ampassimon. The panel and roundtable is going to be moderated by the CEO of Olevo Energy, Alicia Carrasco. I have to say it twice. Next slide, please. So what is Current? To summarize it, Current is a sector association that's now 1.5 years old, as young as the companies that have set it up. And its vision of it is a European power network that uses innovative grid technologies to realize an efficient, renewable, and decarbonized power system. Next slide, please. And the technologies that we are covering, it's a ever-growing summary or group of technologies, is modular power flow control, is dynamic line rating, is superconductor cable systems, innovative sensors, and we work on TSOs, on DSOs, with hardware and software and associated protocols. Next slide, please. This slide I find is really intriguing. It's the Glasgow has just finished Glasgow COP26, and there was a lot of discussion. Is it a success or was it rather missing out? And I do think facts are always better than lots of speculation. On the right side, you see the pledges from Glasgow, which is ambitious. It's 6.3 billion metric tons of CO2 reduction by 2030 from all kinds of sectors. It was difficult to get there. And you saw the declaration on vehicles, on phasing out coal. It's ambitious. However, when you look at the global story for 2030, you see then that a factor of 4.2 is needed, 4.2 more of emission reductions are needed to achieve what was agreed after Paris, well below 2 degrees increase of the temperature by 2050. So we need to have it 4.2 more, and we believe that technologies like ours are decisive to get there. Next slide, please. I'm handing over now to Concha Sanchez. She's the manager of system development area of Red Eléctrica de España, and Concha will give us some insights on the key role of Red Eléctrica, its strategy until 2026, that's today, and until 2030, that's tomorrow, for achieving the Green Deal, new network needs, reinforcements, and also the potential of new technologies. Thank you very much, Concha.
Thank you, Susanne. First of all, thank you very much for inviting us, giving the possibility of sharing our vision, the way we are dealing with these huge challenges for the future involving the system and the grid. If we go to the next slide, we can see first, I think it's a good idea to have a quick view of the frame. Where do we were some years ago, where we are today, and now going to the future. As you can see here, the current situation, sorry, but the slides are in Spanish. Current situation shows that from 1999 till this moment, the emissions, the greenhouse gases has a changeable behavior. We can see an increasing tendency till 27, and then we can observe a not clear, but a tendency decreasing these values. We are talking about the global emissions, and we can see in green in the base the emissions due to the electric generation. We can see how the generation in Spain has changed, coming from 2007 till 2020. And we can see how, for example, coal has been decreasing and decreasing, almost disappearing, how renewables have been taking an important part of our mix. And this is just where we are, but how we have achieved this situation. For me, it's a pleasure. And of course, I have to share in Spain, one of the key tools for this was the creation of the Renewable Dedicated Control Center, going into the observability and controllability of this renewable generation. That's something we started 15 years ago. And this gives us the possibility for changing the share of renewables from around 20 till the current 40-something% of whole generation, electric generation in Spain. Of course, we continue working on these functionalities in our Renewable Control Center, because it will be a key issue for the future, a key tool, and we need more capabilities, more functionalities, and that's something we are working on. If we go to the next slide, please. What's the future for the Spanish system? We are going only to have a very short summary on the main figures. As it's designed in our National Energy and Climate Plan. The Spanish climate plan was awarded as one of the best ones in Europe. And what we can consider for the future? We're talking about the 2030 horizon. First, taking a view on the side of generation, of course, we are going to experience a huge change on our generation capacity. We are talking about increasing 24,000 megawatts of aeolic wind generation. We are talking about 30,000 photovoltaic, 5,000 solar thermal generation. And that's a very, very huge change. Of course, we are talking about decreasing and almost disappearing coal generation. There's a design for nuclear closed plants for 2030. And that's not all. We are not only talking about generation, that's a huge change, but we are talking about increasing, and that's very important, almost doubling, not doubling, but increasing 3,500 megawatts in terms of hydro pumps, 2,500 megawatts in terms of batteries. We are talking not only about generation, we are talking about storage. That's something completely mandatory for this energy transition and being available to accommodate the variability of the renewable resources in terms of the consumption, the exchange with other electric system, and so on. Another important fact is the National Climate and Energy Plan is designing a huge increase of transfer capacity between the Iberian Peninsula and rest of Europe. We are talking about, we have now about 3,000, we can say, megawatts of NTC around this value. We are talking going to 8,000 megawatts. We are talking about 3 new projects, and that's something really important for the Spanish peninsular electric system. What's the goal? The goal defining in our national plan is going to 74% of share of renewables in our generation for 2030. That's a complete different situation that the current one. We talked about 40 something, going to 74 is not evolution, that's a revolution, we can say. I have only put here how a day can appear in terms of generation, involvements. We're talking about electronic of our generation. We are talking about going to this electronic connected to the grid generation. We are talking about certain needs from this generation in terms of short circuit, in terms of giving strength from the grid to this generation. We are talking about controllability. This new shape gives another possibilities. But there are some things we are going to lose in this transition. I think everyone is aware about inertia, stability given in the classic system by the classic generation units. That's something that will give or will lead to a gap, and this gap should be covered by technology, and that's something not completely solved. But we were talking about generation side, we are talking about how to operate, we are talking about storage, interconnections. If we go into the grid in terms of the internal grid and not only interconnections, what's the need for the future in our system? First of all, we have to be aware that renewable resource is quite changeable. It's something that we should learn to operate when we are talking about changes from one hour to the other, indeed in some, not minutes, but perhaps a quarter of hour. And it's a very different shape of how to operate, on how we will operate the system. What's the involvement for the grid? The grid, as definition, transmission grid is the physical set of assets, of infrastructure that provides the possibility of matching this new generation, new consumption behaviors, new tools, accommodating new flows, new power flows, new needs, and not only a question of capacity in terms of giving possibility of connection and capacity in order to integrate the production, renewable production in the system, in the grid. We are talking about a common share for all actors in the electric system. And this is very important in terms of concept, because When we are talking about the current grid, we are talking about operation, but when we are talking about the future grid, we should be providing this communitary service for the system as a whole in order to be able to go on this energy transition, on this enlarging and increasing renewable share in our electric system. These flows are increasing, changing. The direct solution or theoretical solution is you need to enlarge your grid. You need really reinforcements and new infrastructures in your grid. But this is not the point. We are not going to talk about what's the number of the amount or doubling or how to cover our territory with grid. More than this, we should make a clever design of the grid in order to assume we are responsible of first maintaining the quality and security of supply while dealing with these challenges of energy transition. But not everyone will be happy with grid development, and we need grid, not only designing the grid, we need acceptance, we need compliance with other criteria and not only with the electric one. We cannot make a plan in terms of major development of the grid, because perhaps it would not be affordable, not only in terms of economics, but in terms of social acceptance. And this is something very important to know. We are endorsed to participate with clever solutions, using as far as possible different possibilities. We are talking about alternatives and selecting the best one from several points of view. How to deal with this grid development design? If we go to the next slide, please. Well, first of all, in the Spanish system, Red Eléctrica acts as technical advisor of the ministry, of the government, in terms of giving them our technical point of view for grid development. The grid development is, of course, responsibility of government and ministry. But I will try to explain what are the constraints, the factors to be taken into account, and possible ingredients for this grid development. First of all, it's clear energy transition involves to electrification of some consumptions not electrified today. First of all, we need to accommodate new flows. New flows, what does it mean? We are talking about flows from the areas where the resource is present, going into the consumption points, going into the interconnections. And this is something, as I have already mentioned, very variable. We can have a shape of generation in the first hours in the morning, at noon, a complete different one in the afternoon, and of course a complete different one during the night. We should be sure that, I have to remark it again, we are going to a quality and sure and secure of supply, and we have to manage these different and changing conditions. So we cannot make the approach of we are going to cover all situations, all possible situations, just from security of supply, but we cannot cover all possibilities in terms of shape of generation and different conditions. So first of all, we should identify what would be the most demanding needs in terms of grid or in terms of reinforcement in our system. And we are talking about exploring all hours of a year, different climatic years, different situations, and then selecting which ones are the most common, where to put our best interest in terms of grid development. I'm going to talk about, first of all, base case. We are not talking of N-1, but N-1 is another story. Well, we have resources generation at certain area, and we should be able to accommodate the flows to another area. First option, new grid? No, that's not the clever way of designing the grid. First options should be exploring operational solutions, like I have mentioned with our control center and operability issues. Second one, and very important and a very key issue defined from our government for our next national development plan. You have existing assets. You have to take advantage to ensure the best efficient use of the existing grid. So we have to explore, for example, dynamic light rating. We have to explore repowering of existing lines. We have to explore high temperature conductors and several possibilities, including, if available, control devices and so on, in order to look for a solution with less impact in terms of territory. Why? Our national development plan is not only linked to giving this service to the electric system, to the society, the whole society. There's another point of view, and that's the environmental point of view. We should ensure the acceptance and minimizing the environmental impact in our territory. So the no impact is no action. Of course, we cannot afford no action, but we have to explore less impact in an increasing way. So that's on the left up corner, we have several possibilities in order to be taken into account if they are possible enough, what's the service given to the national, to this development of the grid, and then making a selection of several possibilities. Alternatives is one of the key issues for the future. When we are talking about alternatives, we can take into account an overhead line, we can take into account reinforcing an existing one, we can take into account control devices in our grid, we can take into account if we can be able to control or to get any response from generation in order to avoid a not so important new infrastructure. When we are proposing or defining a new line, an infrastructure, that's because we have explored any other solutions and they are not enough in terms of giving the expected response. In this line, the National Development Plan proposal, it was under public consultation some months ago, Of course, for each reinforcement, for each new infrastructure, it's providing the evaluation. And what's meaning evaluation? Evaluation, it's we are talking about what's the amount of emissions avoided, what's the amount of renewables increase we can achieve with this infrastructure, and what's the economic benefit for the system. That means, are we allowing regeneration without going to more expensive fuels, for example? That's something that should be evaluated, assessed, and offered, and giving with a lot of transparency for all public in order to get confidence in what's the decision taken. The result in a year, from a general point of view, lead that this proposal for 2026, that's the horizon for our national development plan, our future national development plan, is the proposal comprises going to repowering 6,600 kilometers of current existing lines. We are talking about 700 kilometers of existing lines with monitoring, with this dynamic line rating. We are talking about using, for example, batteries as element of the grid in order to ensure the best use of some assets. We are talking about Five Sister, we are talking about facts, we are talking about almost anything that could be considered mature and commercial for this forthcoming future. We're talking about 5 years, more or less, okay? And then if we go, well, so the main message here is when you choose to build a new asset, it should be the last option. You have to explore all options before this, okay? And then if we go to next slide, I only want to show you what's the role, what's offering the development of the grid. We are talking about no action when we go to our left side. We are talking about that's the scenario with these renewables corresponding to 2026 scenario. What's the share of renewables we can achieve with this starting point or reference grid, and that's quite below the desired rate. We can almost make the assessment for a ideal theoretical grid without limitation, and what would be this solution. Of course, that's completely ideal. And what is the equilibrium point, the balanced solution for achieving as much as possible the rates in terms of renewable share, decreasing emissions, and so on, with less impact to our territory, respecting economic limits of investments established by law in Spain. And we can share with you the proposal, the National Development Plan proposed, and now we hope to be officially approved very soon. It's able to capture about 70–80% of these advantages. Till now, we have only talked about our mainland system. Imagine what could be the challenges when we are talking about small system, isolated system, as can be the Canary Island systems, without these tools of interconnections, without tools in terms of hydro storage, with less territory, with less stability, then we need, of course, grid, but we need technology too. When we are talking about 2030, this gap between this 67 till the 74% as goal as 2030 horizon, we are talking about not only using the same things, but using these things and different things that should be achieved by technology. Thank you very much.
Thank you very much, Concha, for such a great explanation of what are the challenges for the extension of the grid in Spain. As you say, there are many new things to do, many new actors to include, and you have a very big challenge with this new asset is the last option. So we do see that after your great presentation, that the challenge is not small. And we are now gonna take the opportunity that Karen put us today here to understand what is the vision from the G-Energy, and also to understand from the panelists, also what are the technology toolbox, and also what specific technologies can provide to achieve the challenge with the big bottlenecks that there is, that new assets is the last option. So with this, now we're gonna have a great panelist roundtable. They will do each of them a presentation, a short presentation of 4 or 5 minutes. And afterwards, we will be taking questions to them. So we're gonna have Ricardo from the G-Energy, Norela Constantinescu from ENSOI, Mario Partiño from Smart Wires, Dick Menzies from Ampayos, and also Andrés Ramos Palant from Comillas University. So we're gonna start this round with Ricardo Renedo. He's policy officer of the European Commission. And he works primarily on offshore renewable and infrastructure and on a smart electricity grid. And today he will share insight of the vision of the 10E and the role of the power network and technologies. So Ricardo, if you want to go ahead, thank you very much.
Thank you, Alicia. Just checking, can you hear me well?
Yes, perfectly, Ricardo.
Thank you. So I thought it was interesting that Susanne started talking about climate and Glasgow COP and what is happening at a global level, and the very good presentation by Concha on the ambitious actions that Spain and Red Eléctrica are taking. And what I'm going to explain in a couple of minutes is how to link these two action towards the climate, which are global, and energy, which is more national actions. And for that, I will explain what we are doing in the European Commission on this, and in particular in DG Ener. I work in the unit on energy infrastructure. And indeed, as Alicia was saying, especially on offshore grids, offshore renewables, and smart grids. Just to explain where we are coming from, the whole idea comes from the Green Deal and how to tackle carbon emissions. The European Climate Law, which was endorsed by the Parliament already in June, says that indeed we can achieve the 2050 climate neutrality objective, and that we should. And this is linked to also the climate target plan, which tell us how to do that. And that means that by 2030, according to the studies performed, it's not only feasible, but we need to achieve the 55% decarbonization target. This is the only way to go in the right direction and right trajectory towards climate neutrality by 2050. And what does it mean in practice? That the Commission, and by no means, I don't mean energy at all, but all of the Director Generates of the Commission, we are working very strongly on setting a policy framework that help us achieving this. And this year in particular, 2021, is key for that. It's a big milestone. We have done a lot of work. We have released a comprehensive package of policy proposals already last summer: energy efficiency, renewables, emission trading, carbon border adjustment. And it's not yet finished. We are still working on a second set that will come at the end of the year on decarbonized gases, hydrogen, and methane emissions. So this is a little bit the context. Now, if we could go a little bit to the next slide, please, Christy. Thank you. In terms more in the subject of today, the strategy or the direction that we are pursuing at the European Commission, European Union, is first, let's focus on energy efficiency. It should be the first goal. The cheapest energy is that you don't need to generate. So efficiency first. And for that, I mentioned before the Energy Efficiency Directive. It has a number of updated objectives, including more ambitious targets. Well, the public sector should play an exemplary role. And the focus should be always, as everything we are doing in the European Union level, on alleviating energy poverty and having the citizens in the focus of everything. In this directive, there is also an angle on grids, where we request or we propose that NRAs, regulatory authorities, should look at energy efficiency first when taking any actions or any decisions on cost, that it comes also on the grid. So efficiency should come first, and that also means efficient operation of the grids and these innovative tools that Concha was talking about. Second, we need electrification. And we do think is one of the key bases for achieving the decarbonization goals. More electrification of demand, more renewables, and of course, not everything can be electrified. So far, some hard to abate industries, especially, we will need other fuels, so mostly probably green hydrogen, renewable hydrogen. If we go to the next slide.
Ricardo, sorry to interrupt you. If you can make it short to try to be on time, that would be great. Thank you very much.
Yeah, so I cut it very quickly. On terms of renewables, we are moving to an objective of 40%. This is in order to achieve the minus 55% of CO2 emissions. That means that we need a lot more renewables, but also stronger grids, reinforcement of the current grids, and additional grids sometime to meet this. And then if we go to the next slide, which is my last one, to achieve what I just said, what we are doing is updating our trans-European network for energy. And for doing so, or in doing so, we maintain the cross-border relevance, but we request, or we have proposed reinforcements on the digitalization, innovation, incorporating ICT systems, and with the ultimate goal of having a more efficient and more intelligent electricity and gas, also transmission and distribution networks. So I could talk a lot more about digitalization and other things, but I will stop here and then I can take any questions.
Thank you, Ricardo. We do see and continue that energy efficiency and use things in an efficient way is key for not only Red Eléctrica, but also from the European Union. And now we're going to go ahead with the next speaker, Andrés Galan. He's a professor and a PhD electrical engineer for Universidad de Comillas, and he will discuss mathematical models for transition, spatial planning. Andrés, if you can be short, I will appreciate it very much. So thank you, Andrés. Go ahead.
Next slide, please. Here I'm presenting, so first I'm talking about from the point of view of the university. So we are, let's say, we need to provide tools and we need to support decisions, not only for private company or for the TSO, but also for the European Union in order to come up the challenge itself for decarbonizing the society in general. In particular, transmission expansion planning has many, many complexities from a spatial, trying to cover all the European countries. Also the temporal complexity, meaning that we need to deal on an hourly basis for many years, and also the stochastic behavior of the people or the weather that strongly affects the provision of resources or the provision of demands in the system. So this is a huge mathematical challenge to address all these things. On the other hand, usually we are not dealing very much with the presentation of the next 5 years, but also sometimes we do. However, most of the times we support decisions in the longer term. So for example, 2030 or 2050, as a, let's say, prospective analysis to be used for long-term decisions in the system. Next slide, please. In this slide, I'm presenting two things. One is the map on the right side provided by Red Eléctrica, where they explain which are the drivers for investing decisions, investing in transmission lines. So some of them are security of supply, some of them are high-speed train development, some of them are industrial demand, and some of them are, for example, or many of them are related to renewable integration. And on the left-hand side, we are providing as within on storage as the key element to provide flexibility on generation. We must think from the point of view of the grid of different devices or actions that must be taken into account in the planning exercises in order to provide a strong flexibility in the network. So for example, the facts, the dynamic line rating, switching, line repowering, line reinforcement, all these things, or the use of AC or DC transmission lines, or as we already mentioned, overhead or submarine or underground connections. All these things are the way to potentiate the flexibility of the network. Nevertheless, still, the transmission expansion planning is a very challenging topic, a very challenging models or decision support models in order to help the European Commission or in general any TSO to reinforce or to deal with the integration of renewables or decarbonizing the society. And the latest slide, please. Just as an example, we are now working on several European projects as we are specialized on providing, let's say, the impact or analyzing the impact of the transmission network of the different policies that can be plausible for the European Union in the medium long term, so 2030 and beyond. And for example, typical analysis can be done is let's say renewable deployment, a local state in the rooftop or centralized development, let's say offshore wind or large power solar power plants are impacting in a different way the development of the network. That is a classical thing. For example, the other can be, for example, let's say how we can exploit the connections not only among European countries, but also with our neighbors, for example, the MENA countries, the Middle East, Northern Africa region, and in particular, for example, in this study we did years ago, we provided some insight about the possibility of connecting the southern part of Europe with the MENA countries, the North Africa countries, and which could be the connections in order to strengthen the possibility of importing or exporting from Europe to those countries, or even building power plants in these African countries and importing from Europe. That is all from my side, just in order to shorten my presentation. Thank you.
Thank you, Andres. So we see that there are challenges, new actors, no new lines, energy efficiency, and another challenge is very difficult to model everything together. So it's true that technology is key for the development of the grid expansion and the grid operation. So the next speaker in this panel will be Norela Contastinesco. She's the leader of the innovation at ENSOE, the European Network of Transmission System Operators for Electricity. And today she will describe ENSOE Technopedia and also what the toolbox contains. So thank you, Norela. We are all listening to you. Thanks.
Thank you, Alicia, and thank you for this invitation. So I will try to keep really focused in 5 minutes. So by introducing actually possibly in 1 minute the European perspective of what Concha presented from the point of view of Spain, and what Ricardo underlined as main drivers in this decade. So 2020, 2030. And you see here some numbers, and the grid enhancing technologies and also the innovative technologies are helping actually to achieve these drivers and these developments in terms of race-based electricity. So we have to double the integration of renewables. We will have 3 times more capacity from today from wind and solar by 2030. Then, of course, the electrification, this is going to increase. Energy efficiency will bring down the energy consumption in general, but the electricity will increase, and of course the investments. I would go to the next slide by saying that a little bit also to what Andres was saying before. So the electrification on one hand, the integration of renewables on the other. So they bring challenges, but also they bring actually opportunities, and certain innovative solutions are there and can be integrated in order to cope with these challenges. We have changes in the load. So this the load which was fixed before, we knew it very well in advance, is going to become more uncertain because of the electrification of the transport sector, of the heating sector. The generation, we know that it's less dispatchable because it's based on wind and solar, but there are capabilities which can be enhanced already in the renewables as well, like for example, the grid forming capabilities, and of course the grids themselves. So we have to face a system which is dominated by power electronics. So these inverter-based connected assets, which will result, as Concha was mentioning, less predictable flows and the lack of inertia. However, these developments will come also with the solutions, because we have solutions in the loads, we have solutions in the storage, and we have solutions also in the assets which are used for the grid. So it was mentioned the dynamic line rating, the power and the voltage control devices, system protection schemes, dynamic grid connection, and so on. And by giving these examples, I will go to the next slide to show that all these different solutions you saw on the previous slide, we tried to put them more structured in what we called Technopedia. So we focused now on the TSO actually uptake of these technologies. Of course, I think for the future, we have to also go towards the distribution networks. We classify them in assets related, flexibility related solutions, and also digital fact sheets. You see here that, for example, the dynamic line rating, it's sitting on the maturity, technology maturity level number 9. So it means that it's there. Of course, their integration by, for example, in the TSO business is taken, not by all TSOs in Europe, but by many. And there are future thoughts on how to take it. So this Technopedia, so this tool, which actually is looking at different technologies, of course, it's available on the website. But what is important is that actually we keep the update of these this tool we developed, of course, with the stakeholders, like for example, current, but also others with the DSOs, in order to have all the time present the actual state of the art of the technologies and how this is implemented. If we go to the next slide, I would like just to give you an example of how these few technologies, so we couldn't actually take all of them in all the TSOs, but you see here a little bit of examples on how the TSOs are actually having integrated these technologies into the business. So there is a quite big deployment for example, as you can see on dynamic line rating, or for the optimization of system operation, taking into account the wide area monitoring system, or for example, the distributed connected assets, which are qualified for frequency regulation and congestion, or for asset management condition. And there are still plans to actually go and further deploy these innovative solutions. And I think this is my last slide. Alicia, I see you there. So I think it's okay. So if we go to the next slide, I think there it's the next slide, Christy. Oh, thank you. So it was actually the slide towards the tool. Thank you very much.
So, Norella, thank you very much for sharing with us the toolbox and the Technopedia. I will recommend the assistants to go to the website on ENSOE and check it, because I think there is really a lot of information about what technology providers are doing to provide the services and the products to achieve the challenge that greatest grid operation that's been. So the next speaker is Mario Patiño. He's the Customer Solution Manager of SmartWires, and he leads the teams that is responsible for partnering with utilities, authorities, and energy stakeholders to maximize the use of the system network capacity using modular power flow control solutions. So Mario, we are looking forward to hear how you present on power network optimization, and you give us some examples. Thank you.
Thank you, Alicia, for the great introduction. So I think I will not spend a lot of time on this slide. Christy, if you can just click further to have like the full, I think, you know, all presenters today did an amazing job, say, setting the stage in terms of the trends and challenges we are facing with the energy transition globally. I think we can conclude some few things there. We need more ambitious goals, right? And we really need solutions to, let's say, react fast to these decarbonation trajectories. On the left side, you can see, let's say, the difference between, you know, reacting now with technologies in the near term versus reacting too late on these decarbonation trajectories. Now, all these goals are leading to new challenges. As we all know, for the energy sector, we have massive amounts of renewables trying to connect in the near term. We have huge steps before 2030, as Concha was presenting at the beginning. And then we have a more uncertain planning scenario, as you know, Ricardo and Norella were commenting, due to changes on the load flows, load profiles, etc. So there's a need for grid technologies that you know, can synchronize, let's say, this very fast pace of the renewable development with the actual grid, when thinking about the role of the grid to synchronize all these challenges. So the next 10 years will be crucial. We need really these near-term solutions that can support these early decarbonization trajectories and allow this significant step in the next 5-6 years, but in a cost-effective way. And also, of course, technologies that complement with each other. And, you know, later on today, I think Dink will comment on different technologies. We need to be complementary to each other, not only among us, but also symbiotic and synergistic with, let's say, long-term transmission infrastructure planning. So if we go to the next slide, we will see that this main limitation for the renewable integration today are mainly there's no transmission capacity to advance renewable interconnection with the existing grid in the pace we would want to, right? And then we have also the rigidity of the grid, not flexible enough for intermittent energy sources. And as was already commented by Andres, these grid congestions can be alleviated by using the so-called grid enhancing technologies. Norela was speaking a little bit about those as well. And taking about an example here, the modular power flow control technology. With this technology, let's say the utilization of the existing grid can be optimized. The diagram below shows how this technology, let's say, allows for an efficient use of the existing infrastructure. And this is a key enabler for the energy transition, let's say, releasing the cheapest possible energy, as Ricardo was saying, which is the ones which is already there in our grid. So these are modular power flow control devices that can be, let's say, not only installed in the near term in less than 1 year, but also is a technology due to its design that can be redeployed to different zones of the network, which is ideal for the uncertainty we are living in today's paradigm. And this is a modular technology that can also be relocated if the transmission needs change. And this is something that is crucial for today's scenario, right? Horizon 2026 and the next 10 years, you can see below what we usually and traditionally used for grid planning, right? It was a more certain word. We had need that was increasing, and then we had an available capacity, and we used to be planning for long-term solutions, and that's what we see on the right side of the diagram. You know, we were planning based on energy trajectories with a very certain planning scenario for HVDC links, new circuits, new substations. But what you can see today is that there is a gap marked here in green in the near term, where we need this grid enhancing technology that can be used, let's say, in the near term to collect all these benefits and also to allow for significant steps in terms of decarbonizing the grid in the near term. So if you click further, Christy, we will see there, this is the area where we call, area for grid enhancing technologies for optimizing solution, optimizing the utilization of the grid today in the near term, that are quick and flexible, that I can, let's say, reaccommodate in the grid depending on how the grid needs evolve, but then also that are complementary and synergistic, not only with different grid enhancing technologies, but also with the longer term solutions. And if we go to the next slide, I had some example of how this kind of technology has accelerated the energy goals in different regions. One case I wanted to bring up here was the case with the Australian grid, with Transgrid, where this technology is being used for congestion management in real time. So due to the geographically dispersity of the wind farms, these devices are being utilized to optimize in real time by managing the, let's say, the impedances of the system in accommodating, let's say, from the wind intensity. So this is avoiding curtailment. This is optimizing transmission margins, and this is also avoiding the impact in terms of territory and environment, because this, let's say, avoided a disruptive project that was crossing one national protected park. Then we have one case in the UK where this technology was utilized to release more than 1.5 gigawatts of grid capacity in less than 1 year to interconnect, let's say, renewable energy in the north of the country. This allowed for a quicker, let's say, alleviation of this congestion 3 to 4 years earlier to the initially planned infrastructure. And then in terms of savings, let's go back again. We need to do all this transition in a cost-effective way. It saved the end customers more than 490 million. And then finally, this is the last example that I wanted to bring you today, the case in Colombia, with utilizing these modular power flow controllers to redistribute the power flows and allow for additional 200 megawatts of interregional capacity in less than 8 months. And this allowed for, let's say, new renewable interconnection projects that were waiting for infrastructure plans and projects for many years and were not allowed to connect. Now this technology advance this energy agenda of the government, and then thinking about the flexibility, not only in terms of operation, but also in terms of decision making. Once this grid infrastructure project is finally online in 6-7 years, part of this bank will be relocated to release additional 1 gigawatt once, let's say, this line is energized. So infrastructure is very complicated. We need these kind of technologies that can synchronize the pace in which we are developing the renewable energies, but that give us also flexibility in terms of planning, because we are living today in an uncertain world in terms of planning scenarios with all these challenges that have been discussed today. That's all I had. Thank you for your attention. Back to you, Alicia.
Well, Mario, thank you very much for showing us how SmartWire's modular power flow control, that solution is offering offered to maximize the use of the network capacity, and also together with saving for the system and the consumer. So I think this combination of these two targets is exactly a very good input to the energy transition. So before we move to the next speaker, I would like to tell you that Norella shared with us in the chat where to find Technopedia from ENSOI. So if you go to the chat, you can find the link to the Technopedia. So our last panelist is Dick Menzies. He's the Global Sales Director for Ampatsimon. He's based in London. And today he will outline the benefits of dynamic line rating across Europe. So Dick, we are all listening to you. Thank you very much.
Good afternoon. Next slides, please. Yeah. Very quick about Ampatsimon. We are founded 10 years ago as a spin-off of University of Liège R&D project on sensor-based DLR technologies. And over the last 10 years, we evolved as proud to say global leader in sensor-based DLR forecasting technology with more than 400 overhead line sensors installed over 100 lines globally. What is sensor-based dynamic line rating? Sensor-based dynamic line rating is a system of overhead line sensors installed to measure conductor and real-time environmental data in order to first to monitor the overhead power line. Once the monitoring happening, the next stage is providing more and accurate visibility of the asset condition, in this case, overhead line. And then once these two steps completed, then moving to the last stage, which is determine the true extra capacity available on the existing line within its safe use limits. Next slide, please. We can split the line capacity rating measurement mainly into two categories. One of them is the direct measurement and the other one is indirect measurement method. The first three types you see on this slide reflecting the indirect measurement methods, which are in a nutshell using weather stations and modeling. The first one is static line rating, which is the most conservative line rating considering really the worst case scenario. Second one is the seasonal one, which is applying static line rating defined by the seasonal impact rather than using flat and constant line rating throughout the year. Third one is the ambient adjusted rating, which is a rating computed with ambient temperature, simulated with sun radiation and minimal wind speed defined by the utility. They are proven to provide 5 to 10% more capacity on the top of the static line rating, but it is really very risk-free and it really leaves some capacity gains on the table. And the last one is direct measurement method, which is the sensor-based dynamic line rating. It's using the devices or sensors we call that directly coupled to the line, measuring conductor temperature, tension, sag, and clearance, from which line's terminal rating is determined real time. And it's proven that it provides more than 40% capacity than static line rating. And you see that there's one point that it considers the wind cooling, which I will refer a little bit more on my last slide. Next slide, please. This slide is quite a busy slide. I'm not going to take you through, but this is just providing a bit more insight regarding the process and also comparison between these two methodologies, between direct measurement through sensor-based monitoring versus indirect measurement through model-based simulations. The bottom line here is that sensor-based real-time monitoring and measurement is a proven DLR technology, providing real-time, higher accuracy and higher gains in the capacity of the respective existing line. And on the next slide, I want to show you maybe on the real-time example. This is, you can see that this is the differences between these two methodologies. On one of the lines, our sensors are installed. As you can see that load current of the line, which is the bottom, operating 75% of the static rating with the safety net. And you see where the static rating stands. And this is a measurement over 4 days period. And you can see the capacity gain coming with the real-time AAR. And on the top of that, the green one is the real-time DLR coming with the capacity calculation with our sensor on the line. And also we are able to provide some ahead forecast, like between 4 to 6 hours for ahead forecast or day ahead forecast. But this is just an example that I want to share with you from a real life example that how real-time DLR can provide significant capacity gains on the existing lines. And my last slide is, it's really what I mentioned to you about the wind factor. Of course, there are different weather parameters playing into the dynamic line rating, the ambient temperature, solar radiation, but obviously the most important weather parameter is what we call effective wind, which is directly monitored on the conductor by a sensor. And what we mean with the effective wind is that the vibration and swing angle measured by accelerometers and converted to the effective wind, which is not only speed of the wind, but also the angle of the wind. And that provides a significant, as you can see, like 35 or 40% capacity improvements. And the reason why we think that the sensor is really critical to measure the wind impact, because we really observed different weather station impact on the wind. And we found out that many times they are not in the right location or right height, or anemometer is not really even measuring the lower wind speeds, like below 2 meters per second. And that's the reason I just want to highlight to you is in the sensor-based dynamic line rating, wind is the most influential and probably the least predictable capacity factor, which of course our sensor provides lots of insights regarding what we can gain from that. That's pretty much from my side, and I'm looking forward to hearing your questions. Thank you.
Thank you, Dean. So now, first, thank you to all the speakers because you really kept it on time. So we have now time to questions. So I will really recommend you to raise some questions. We have a question from Elena, Pilar Muñoz Elena, that she's telling us whether in the current context of record high prices in Spain, whether there are any action expected to tackle the risks of energy poverty due to this situation, and how to adapt the narrative of climate objectives in this context. Who wants to go ahead and reply to the questions?
I can take it, Alicia. Ricardo speaking.
Thank you.
Yeah, so yeah, thanks, Pilar. So on this, basically what I said before on the policies that we are developing at the European Union level, they still hold. So we still believe the right way forward is having well-integrated markets, increased uptake of renewables, more energy efficiency, and that will keep energy prices affordable for all the consumers. And the consumers are always in the center of the policy. But nonetheless, it is, as the energy prices are showing, key, fundamental to have vulnerable consumers well protected and always in the center of the scope. So for that, what we have done on the Commission, we have developed a toolbox that should help member states in identifying measures that they can implement at national level in both the short term and long term. So in short term, things like emergency income, supporting energy poor consumers, or deferrals to bill payments, or temporary reductions of taxes, for example. But also long term, so increasing even more the investment in renewables, developing energy storage, and doing things like possibly cross-border regional risk assessments when it comes to gas. In addition to this, we proposed in July what we call a social climate fund, which, if confirmed, if approved, it would help directly households, but also transport users, micro enterprises, with direct funding from the EU. We're proposing over 70 billion euro. And yeah, also it could provide direct income support for vulnerable households. So at least at European level, I think this answers a bit the question. Thanks.
From a macroeconomic point of view, the high prices of let's say of some fuels, in particular gas, are good news for renewables. So as the prices are high, you are investing, or you promote the investment on renewables, and also you promote the investment in the network, because these are the main resources in order to, in the long term, to decrease the price of the electricity. Nevertheless, in the short term, that is causing problem for many people that is, let's say, has not enough money in order to make the payments of the energy bill or the electricity bill. And the measures that Ricardo has already mentioned can contribute to alleviate the personal problems that they may have in facing the bills of the energy.
Mario, do you want to respond to this question?
Yes, Alicia, sure. So I really second, Ricardo's and Andres' thoughts there on, that it will be a trigger or let's say a motivator to invest in renewable development and invest in the grid. And there are also, let's say, components of the electricity rate, the electricity bills that are related to distribution congestion costs. And, this fraction of the tariff can be, of course, greatly positively impacted by these grid enhancing technologies that we are speaking about today. In Colombia, there's a case, for example, where modular power flow devices were installed actually thinking about cost reduction for the end users. And there in Colombia, as an example, there are 6 components on the energy rate, right? And then 2 of them are related to distribution costs and then transmission congestion costs. And these 2 factors were, let's say, significantly reduced by managing the power flow controls and alleviating the congestions in 1 year. So this is just as an example on how these grid enhancing technologies can also impact the energy rates, thinking about the end consumers, as Ricardo was saying, as, let's say, the center of the whole energy transition vision.
Thank you all for the answers. I have now 2 questions that I think can be answered by Concha. The first question will be, given the massive investment needed, how should national development plans and the 10 years neighbor development plan account for technology solutions in addition to grid expansion? And the second one, Concha, sorry to go to you with 2 questions, is how does Spain ensure that the network delivers the ambitious targets?
Thank you, Alicia. Well, first of all, when we are talking about technology solutions, it's a very accurate term to say in addition to grid expansion. When we figure about grid expansion, we are talking or figuring about lines, about transformers, but technology is a part of the grid. The key issue is we have not only the opportunity of using technology for existing assets, that's a first step, but we can't count on technology when we are designing complete new solutions. For example, the classical solution for certain need could be one line or two lines or a higher capability line. But if we mix this with technology, we can ensure to reach a more efficient use of the capabilities without increasing the number of transmission assets or their capacities. So we are making a clever, more efficient design. So I think that the right use of technology and classical grid solutions is this hybrid or mixed solutions in order to be able to comply with efficiency from the terms of efficiency for investment and for the system, but efficiency in terms of territory, environmental impact, and so on. So for me, it's clear we should take into account these both possible ingredients in our future design. When we are talking about this ensuring that the network delivers the ambitious targets, well, first, this is something coming from the way the future grid is assessed. We are talking about any proposed development, any proposed element should be assessed in terms on how it will support or give any possibility for achieving the targets. That's the first step in terms of designing. We are designing with these targets always in our mind, and not only in mind, by assessing them using the CBA methodology, developing this CBA methodology, and so on. Ensuring is very difficult to say. Ensuring network development, it's not designing network development. And here we have these issues about periods when the necessity is going to appear, when the solution can be developed. Sometimes certain infrastructures needs time to be to do their tramits, environmental tramits, and so on, designing and building. And sometimes we have affordable solutions for transitory periods and so on. I think the key issue here is not only a clever design, but clever communication involving all actors in this grid development in order to ensure they are interested in this new grid, in this service that the new grid is giving them. And that's something I think all of us are looking for, not met or always met in the past, and this is one of our main challenges.
Thank you for your response, Concha. So we have two more questions. The next question on how complementary are optimization technology, I think can be answered by Dave and Norella, and then we will go with the very last question. So Norella and Dink, if you want to go with the responding to how complementary are optimization technology. Thank you.
Thank you. I will start by saying that, of course, I think it was mentioned by Ricardo in the beginning. So we have to look also at the costs. So wire, non-wire. Concha said, so in addition, so we will need, of course, the grid development, but we have also the option to use today in the existing network these innovative technologies, but also to take into account for the future design. And here I mentioned few technologies there. So to increase the grid capacity, the power flow control devices, voltage control devices, and so on. Of course, I think it was mentioned by somebody. We have to look also at limitations in the sense of a grid, for example. So the new infrastructure will have practically no limitations in terms of the use. Then, of course, we have different technologies like DLR or system protection schemes, which will have certain limitations for the use. And we have also to look at what we need in terms of energy capacity. So if we need to increase the energy capacity and so on. So for example, here, of course, the interconnectors are good, but also the power, like limitations in the congestion issue. I would like to answer, if possible, to a question which I saw in the chat. So
please go ahead.
These innovative technologies. Yes, today the system, so the regulatory system, is CapEx oriented. And we started to exchange a little bit with Acer, so how we can move forward. And of course, in order to take these innovative technologies into and to integrate them, so to be able to finance afterwards, and because these are, of course, not only CapEx, so they are more software related, so it's OpEx. So of course, we have to cover these costs, and sometimes maybe it's a need to have an incentive in addition to have these technologies into account.
And I think from the grid capacity optimization perspective, I mean, we heard from our panel speakers that building new grid or building new lines are, one solution, but it's quite a complicated and time-taking solution. The best way is that how we're gonna the best use of the existing lines. It's not on the transmission level, and as well also on the distribution level, because currently that's one of the things that also we experience, that the congestions are not only high voltage, but also medium voltage. But at the end, the use case for, like, the one that I can talk on my behalf is the dynamic line rating. Is normally the main use case that we see is that how we can integrate more renewable energy resources to the grid without any reinforcement on the grid. But there are other use cases as well, which is helping with the congestion of the grid, or congestion of the grid, like relaxing the congestions due to the increasing load. It's one of the, of course, the use case that we can bring to the dynamic line rating as one of the capacity optimization tool, improving the economic dispatch scenarios for like N-1 kind of contingency. And the other one is that, of course, the interconnectivity between the countries, how we can, the technology can help as well, the maximizing the transit on interconnectors, or what we call bottleneck topologies. Therefore, I think there are many use cases, and this is a proven technology which can really drive to optimize the existing use of the grid, or in this specific case, overhead lines.
Thank you, everyone, for your responses. So we have one more open questions that I will share, and any of you that want to respond to it, just please feel free. The question is the investment framework for grid owners, operators, the right one?
So I thought that I gave a little bit of insights in that one. Of course, there is the regulatory framework, which is today in place. So of course, more CapEx oriented. but we start to see, probably we will start to see an evolution due to what Ricardo was saying. So we have to uptake the digital technologies, we have to uptake the innovative solutions, and therefore, yeah, the regulatory framework has to be adapted. I hope that I answered, and I think we can discuss, of course, also with the stakeholders how this this is done.
Yeah, and I can maybe add also, I fully agree with Norella. And indeed, in some countries at least, there seems to be more of a capex oriented system development. I think an interesting element in this is looking into the best practices report that Acer does every 2 years on tariffs, both at transmission and distribution level. And well, they should do the next version, I think, is next year, and hopefully they will give some interesting elements for countries, for regulatory authorities to see how other member states, other countries are incorporating efficiency and innovative technologies in the tariffs, which is at the end of the day what gives the financial incentive to the TSO. This is one thing. I think also what I was saying before on the update at EU level, there are two pieces of legislation I think are interesting here. The 10E, so I was saying we are updating it, we are proposing and currently negotiating with the policymakers to incorporate a more innovative approach towards the element that can be considered projects of common interest. So I already put some examples before, and also in the energy efficiency directive. So we also encourage or propose to encourage regulatory authorities to incorporate this efficient operation of the system in their national actions. So I think the current setup with the proposed changes, it's in the right direction, and of course, a lot of the work at the end of the day needs to be done on a national level.
Thank you, Norella and Ricardo, for these two answers. And now I'm going to pass to Suzanne, that she will run the conclusions for the webinar today. So thank you, everyone, all the panelists. Thank you, Concha.
Thanks
and all yours, Suzanne.
Yes, I think it was thanks a lot, Alicia, also for an excellent moderation. It was very impressive to have this journey for 1.5 hours with many Spanish-speaking people in English, also from European Commission, starting with Concha, that emphasized alternatives is one of the key issues of the future economic benefit from a system perspective. I quote Concha here. This is the steps that the network transmission plan for Spain has to take for 26, which is today in a way. And it's saying they're also in line with the principle of maximizing the use of the existing grid. 69% of the connection of new renewable generation will be made at existing or previously planned facilities. So that's quite a big challenge. Only 31 is new proposed actions. That's where we are. We are waiting for the plan. Next slide, please. So I also wanted to emphasize this is a huge basket of reports. On the very right side, you see the forthcoming report by Current. I come back to this. But you also see European Commission work by ECORIS. Do current regulatory frameworks in the EU support innovation and security of supply in electricity and gas infrastructures? This is a great report that shows where countries, where member states are in terms of incentivizing new solutions. We have Wind Europe that has produced a report on the need for optimization solutions in order to avoid curtailment. The sister association of Current Watt has done an impressive report on several of the states of the US, looking here what they call unlocking the queue, which means to get more renewables on stream. And Norella presented the Technopedia that is really a very important reference to many. So now, and on the right side, you see the Betriebsmittelstudie. It's a German publication by the German Ministry for Economics that looks into operational tools, also what Concha said, explore operational solutions. These things are there and are presented. Next slide, please. So here, this is a brief ahead of release overview on the study that Current has commissioned to a very well-known German consultancy, Consentech. We will release it in the Infrastructure Forum next week, and also on 8th of December at a launch event. So this study shows, you just go briefly back, yeah. So it shows that 90% decrease of congestion cost is possible if you combine the solutions. You see here quite low congestion costs. That is related to the fact that the basis for the simulation was the 2019 TYNDP. Today, we are already only in Germany at 1.8 billion euro congestion cost. But the principle is what is counting here. The combination of those tools are shedding 90% of congestion costs that ultimately are paid by the customers. Pilar was asking that question. How can you help the customers in the current price situation? The next slide shows indeed the event that we have. The benefit of innovative grid technologies make Europe fit for 55. We launched that study on 8th December 2:30. We have a webinar and also, as I said, in the Infrastructure Forum next week. The next slide, please. So this is a bit the mantra of Current, our association, what we want to see. And a lot of it was said by all the speakers. We want to see an emphasized grid enhancement in the Green Deal implementation, the energy efficiency first principle. For networks, it means not only losses, it means also clearly the system perspective. Again, that was referred to by several speakers, starting with Concha. A Renewables Energy Directive needs to include this reference to avoid curtailment, unless it's the last 2%, where my understanding is that it's better to curtail than to connect those that becomes too expensive. Offshore requires a sound technology aspect, and Tenny, thanks Ricardo for mentioning that you foresee optimization solutions. And then it is a part of electrification and digitalization, and we need to have the costs kept controllable, and customers have to be active. In my country, Germany, it is also the TD component and taxes on the final customer, the energy prices. It's just not anything that will make people more reactive. And I think we share all the common objective to make the transition possible with the needed investments in the grids. In Germany, 100 billion to 2030. In Europe, it's 500 billion to 2030. It's huge. We want to see this happen, but at the best possible cost. Next slide, please. And yeah, that's the end. So I just want to thank all the speakers for great contributions. We have registered today's webinar. Thanks to all the participants for very good questions. And also thanks to Christy for making this event possible from the technical side. Many thanks, and see you hopefully in our next event for launching the concept study. Bye-bye.
Goodbye.
Thank
Bye.
you.
Thank you very much.
Bye.
Thank you.
Thank you.